So this talk is about getting documents into Solr and about how to enforce the security of documents once you get them into Solr. And we're presuming you start with something that basically is, for lack of a better word, a content repository that has some kind of security model of its own. So I'll be covering that, and I'm going to be talking about Manifold CF, which is an Apache incubation project. It was originally part of Metacarta, which is the company that developed it. It was developed for 5 years, and then it was made open source, entered the incubator as a sub-project of Lucene, then became, after that, an incubator project which would actually... I'll try to stand in the light, okay. But at any rate, it became a sub-project of Lucene, then it became an incubator project that was intended to be a top-level project, and that's kind of where it stands now. It had 2 name changes, and now it's called Manifold CF. And basically, we're going to talk about Manifold's way of mapping repository security to documents that you actually index into Solr and how we do that. And it turns out that it is generally useful for many kinds of repositories, not many of which are the open sort. So it's a little more difficult to demonstrate that in a presentation, but we have panelists who will basically tell us a little bit about what they've done to use Manifold CF to secure documents for clients. And so that is kind of the thrust of the presentation. I'm Karl Wright. I have been the principal software engineer, or a principal software engineer of Nokia since Metacarta bought Nokia about 1.5 years ago. Before that, I was a principal software engineer at Metacarta, and I work at Nokia in a totally unrelated capacity that is interesting to me. It is interesting in that it also involves Lucene and Solr, but it basically is in making location search better. I'm the designer and the original implementer of Manifold CF, and I also am the author of Manifold CF in Action, which, there it is. And I'm a committer, obviously, for the open source project. And I have other interests, but those don't really figure into this. So, you want to search a repository and you want to use Solr to do it. We got to get the documents into Solr so we can index them, and then we also have another problem. We're going to call him Vinny. Chances are you already know who he is. You've got him around somewhere, and he's the guy who basically is responsible for making sure that your organization's content is not actually seen by people who aren't supposed to be able to see it. And that doesn't mean people outside of the organization necessarily, but it means people within the organization who, are maybe low-level employees and they don't want to see like high-level security or high-level strategic documents or things like that. So his job is to make sure that whatever you put together for searching doesn't let that get through. And he's not going to let you have access to his content until you can show that. So now we have Manifold, which basically comes into the picture to try to help solve this problem. Manifold has a plug-in architecture, which basically means that you can write a connector to many different kinds of system. There's 3 different kinds. One of them is the repository system where documents are pulled from. Another kind is an output system where you're basically going to be writing documents to. Usually that's a search engine, but it could be other things. And then finally, there is a third kind of connector that is called an authority. And that basically is designed to retrieve information about a user at search time to be able to figure out what sort of access tokens that user has. So Manifold CF includes many different components, but the ones that are interesting to us at the moment are a user-facing UI, which is designed to let people set up searches, or not searches, but index operations, an API, which is a RESTful API, and an authorization service, which basically is the thing that allows you to ask Manifold, is this user allowed to see these documents? And this uses a query restriction model to do its work. As you can see from this picture, which I'd love to wander over there, but they won't let me, Basically, there's a repository. The documents from the repository get sucked using Manifold CF into the search engine along with their security information. And then when you go off and you do a search at the top, your search request is modified in such a way that it actually will only return the documents that you're allowed to see. That's the general idea. So that model is called query restriction, and Manifold implements query restriction by basically sending document access tokens to the search index along with the document content, which means that the repository connector that you used, that you plug into Manifold, has the responsibility of picking up not only the document's content and its metadata, but also security information. And we call these things access tokens. We call them access tokens because we don't want to call them ACLs because those are lists. And we also want to try to distinguish them from the kinds of things that might actually already be in a repository because they're essentially arbitrary pieces of content. The repository connector may choose, along with the authority connector that's designed to grant the authority to these things, it may choose to map the tokens that come out, or map the ACLs that come out of whatever repository you have into pretty much anything that will do the job. So they may, for example, for Active Directory-based systems, look like SIDs. But then again, for something like LiveLink, they may look a little bit like what comes out of LiveLink, but they may also have certain special ones that we add for like taking care of ownership. So there's a couple of things that will be different. So they're not quite the same. So there are separate bins that we do put together for allow tokens, deny tokens, file, multiple folder, and share level tokens. So there's actually n different things here, but in practice we only use 4 because the generic multiple folder construct is not actually used in Active Directory in any way that we could determine. So what winds up happening is there are really 4 different kinds of things you need to store in your index. And Manifold CF knows how to populate those 4 different members of the schema. It knows how to populate share tokens for allow, share tokens for deny, and file tokens for allow, and file tokens for deny. And if this sounds a little bit like Active Directory, well, it is a little bit like Active Directory. Active Directory is one of the most complex authorization systems we know of, and it turns out to be a reasonable thing to basically work with, to have the 2 levels. So the authority service's job is to map usernames to access tokens, and specifically the ones that belong to the user. There's no choice of allow or deny in this situation because effectively they're what belong to the user. The allowness or denialness, the allowness or denyness of the token is basically attached to the document, not coming from the user. And then the Solr search component, or query parser plugin, is basically designed to work within Solr, communicate with the authority service, and do the query modification based on that. And that's what the architecture looks like. I'd love to go over there and point. But effectively, you can see on the left the Manifold pull agent daemon, all the repositories with the repository connection. Solr is at the bottom. And you can see that documents and access tokens get chucked into Solr through the extracting update handler or whatever you prefer. And on the right is the authority service with the authorities. And at the very bottom right, you will see the username comes in and user-specific search results go out, and that's the idea. So in that picture, you saw a pull agent daemon, and what does it do? It basically pulls documents from the repositories continuously or in a schedule, hands them to the output search engine. It's incremental. It does as little work as it possibly can. It keeps track of versions of things that is fetched. The kinds of things that it keeps track of for version information depend on the repository, and they can be anything that you want, anything that the repository needs. Technically speaking, you may need to keep track of ACL information in there too, if it turns out that the sorts of ways you can identify a document's version. Basically, do not keep track of changes to ACLs. And we've seen that in a couple of repositories, that's for sure. So it basically does the document's access tokens as well. And what does the authority service do? Well, these guys, they get on buses and they go to places and they say nobody expects the Spanish Inquisition. But what does it really do? It basically goes, takes names, and the names come in as Active Directory looking names. Active Directory authorizes, or rather authenticates, something north of 95% of enterprise systems these days. So it's kind of silly not to work with that general picture. But there's nothing that says it has to look like that. If you want to use something that is a little different, that's fine, but you will find that the authorities that have already been written, basically do expect it in this form. And access tokens come out. And when they basically come out, they look like something at the bottom of that list. So there's a curl command out there looking for the username foo@bar. And you get back out a little bit of information about that, which basically says, hey, I couldn't reach the Spanish Inquisition. I don't know what happened to them, but they're not there. And that's informational only. And so the token that's associated with that, the access token, says my authority is a dead authority. That allows us to basically exclude or turn off access to documents that shouldn't be seen if the authority is not working. So the other authority, the null authority, basically responds with the name of the user. And why did I put that in? Well, the null authority is a sample authority. All it does is echo back the name as an access token. And it turned out to be very handy for writing the book, because it turned out that it was not actually very easy to recommend in an example that people go off and connect to some Active Directory domain or live link instance, because these things are all very hard to set up. So you can basically see, though, that you're going to get something back, and you can certainly play with it and make your setup actually do something useful even without having a lot of infrastructure. Okay. So what do you have to do to Solr to make all this work? And that's a really interesting question. You have to, first of all, put fields in the schema to contain these document access tokens. So you need a field for the document level allow, the document level deny, the share level allow, and the share level deny. And you need to add something that's not necessarily in Solr at all, that authenticates a user and obtains a username. So, mind you, there's two parts of this process. The first part of security is basically figuring out that you are who you say you are, and the second part of the process is actually figuring out what you're allowed to see, since we know who you are now. And we don't actually try to handle the authentication part. We'll leave that for Jazz or whatever other plugin that you might have around. If you're doing this under the Apache web server, there's a modauth_curb module that will actually talk to Apache. Excuse me, it talks to Apache just fine. I meant Active Directory. So, so there are plenty of ways that you can do this. But then once you're all done figuring that part out, the next thing to do is add a search component or query parser plugin to restrict the incoming query and do the query restriction. And it's important to realize that the Solr component is not what does all the hard work. Basically, all it does is add clauses to a Boolean query that rep for each token that comes in. It's usually not even a problem that there's a lot of clauses to add, in the sense that it's unusual to see a user that has more than a couple of hundred tokens. That's not true for some kinds of repositories. However, Documentum is a prime example of that. It can sometimes cough up as many as 12,000 tokens we've seen in some installations, and that's because Documentum has a very interesting feature, which is that they give you a unique access token for each folder in the whole system. But you can turn that off in the Documentum authority if you aren't using it. So you don't have to live with Documentum's questionable design decision. Okay. So Manifold CF in action provides a sample search component, and in the upcoming version, the upcoming release of Manifold CF, there are also pre-built Solr search components that do this. There's one for version 3X, and there's also one for trunk. And since we can't get an answer out of the Solr guys exactly when they're going to ship Solr, I think it's probably wise to expect that the 4X one is going to need to change as they change stuff, even though it's not very complicated. So how are the 4 token types related? And this is basically almost a little bit of a refresher on how Active Directory does things. But the share and the document levels are computed independently, and an included document has to pass both levels. So for each level, deny tokens exclude, allow tokens permit, but deny tokens always win over allow tokens. So if a user has something that's in the deny field for the document, if they have an access token that's in the deny field for the document, the user is not going to see that document no matter how many allow tokens they've got. Secondly, there's a special meaning for no tokens at all at a level, and that's that it's open. It's a public document. That is also standard practice for the way Active Directory works. In Solr, we handle that by feeding Solr a default token. Or actually, we don't feed it. We basically recommend that you set up the schema so that that field actually contains a default token. And that way, if nothing is actually sent in, it's going to wind up with something that we know what to search for to basically guarantee that you're allowed to see the document. And Active Directory does the same thing with SIDs. And here's an example. And I was going to, once again, point at this. But you can, you can have some fun and actually look at this. Here I've tried to combine examples of both document level and share level pieces. And things that may not be obvious at first, but not picky and share controlled are seen by the exact same people here. Share controlled is seen by, let's see if I can figure out who share controlled is actually seen by. It's seen by T1, T2, and T3. Not picky is seen by T1, T2, and T3, but it's because it is a document level permission in the not picky case, and it's a share controlled authorization on the last one, or rather a share managed one. Very secret is been set up in such a way that nobody can see it at all because it has a deny token and no allow tokens anywhere. So how could you possibly see it? Even though there's a deny token, that all that really does is tell you that, that basically it's not open. So it's not open, but nobody can see it. So good luck there. And insane is seen by people with only T2, and I said it's insane because nobody would, in their right mind, would actually set it up this way. So what's still missing? Well, basically we get documents and authorization into Solr. We've covered that. Getting information from a user, we've covered that. Modifying the search to enforce security, we've done that. But we haven't covered authentication. And I alluded to this earlier. There's your solution. And it's possible that Manifold CF will actually do this at some point, that will give you some sort of component that would make that much easier, a JAS plugin that we write as opposed to one that you have to go and find. But that's not the case now. So who is actually using this system? A lot of Metacarta clients actually did. And frankly, since Metacarta was bought and then its assets were resold, I'm not really sure who is currently doing what anymore. I'm not privy to this, but I know these people used things at one point, up to about a year and a half ago. And these people, do you think they care about security? I think the only people who really don't care about security is the little red box in the lower left-hand corner. So, I was really a little bit concerned about putting things about the Spanish Inquisition into a presentation that was in Barcelona, so you have to give me some slack here. Before we start our QA panel, 4 points. This is a good way to do repository security. It's pretty fast. It's set up. This is what Manifold CF was meant to do. And basically, it does convert pretty much any repository you want to into an AD-like security model that is flexible enough to do pretty much anything. So that's it for the moment. Shall we set up our Q&A session? Sure. So today I have, and they're going to hate me because I'm going out of the light, but today we have Eric Pugh and Abe Shinichiro, both of which are users of Manifold CF or who have clients who are users of Manifold CF.
So let me go ahead and preface, I hate security. I'm like the complexity that it brings to everything. And I think Solr has a potentially slightly unfair reputation of we don't care about security, right? A lot of people have that thought that the Solr search engine, well, how do I do security? And sort of the Solr, typical answer is, well, that's up to your application. You figure it out. I think that's one of the things that Manifold has really brought to the table is you can now answer, if you're doing your comparison between search engines, that yes, there is an actual story about how to do document and repository level security. So with my client, we're working with anyone here familiar with like Oracle label security, right? Okay, so we're working with that. And the way we implemented it first was when we were indexing all our data, we would just extract all of the Oracle labels for each document and store that as part of our documents. And then every query that comes from the front end, we actually get a very, very long list of all the labels that they have. And 100 or 200 labels is pretty common, and there's a couple of people who have like 1,000 labels. And we did the first cut all by hand. So it's just filter queries in Solr, matching, and a big long OR statement. If you have any one of the labels, then you get to see the document. So not a super sophisticated system. We have seen a bunch of problems with the fact that the caching is a critical problem, right? If in this room, if we are using Oracle Label Security, it's very likely that all of us have different label patterns, right? And that means that Solr's caches are getting filled up with all these different, we can all ask for the exact same query, right, but if all the labels are slightly different, they're all getting indexed and stored separately, which means auto warming is more expensive and all of that. So we are in the process of using Manifold right now. We're just doing it. We don't have the concept of a share at all. Everything is just a document or a file level. And one of the things that we do like is that we're now able to authenticate just using a unique token, a user ID. Right? So instead of handing in 1,000 different labels as part of our query, we just say ePew ePew and a domain, and Manifold, the code behind Manifold takes care of figuring out, okay, what are all the actual tokens. The other part that has been a struggle with Oracle Label Security is that Oracle manages all the labels, and it can rename them or change them at its own will. And right now, manually, we don't have a very good way of detecting when those things have changed. And so we're doing periodic full reindexes of our 200 million documents, partly just to pick up on those types of changes. And we're also forced to kind of do updates on all our documents. we're not there yet with Manifold, but we're hoping that Manifold's going to give us a better framework for monitoring Oracle and querying for updates to the labels so that we can apply them a little bit more intelligently. We also have hopes that we're going to move away from the Oracle label security the way it's done to something that's maybe a little bit more rational. And so the advantage that Manifold will give us there is that it'll be a general framework, and we'll just implement a new connector, a new authority type, versus starting out from scratch and rebuilding everything. So the rest of our search application should hopefully remain the same.
So can I just answer a little bit about the security question also? You can hold on to that because I got the mic. Not the security, but the caching question. One of the things that is important is remembering that since authorities are always queried for every search, is to make that cached. So there is caching built into all of the authorities that then benefit from those caching, the Active Directory authority included.
Cache the set of documents
It doesn't cache the set of documents.
That's the same for every query, right?
The set of documents that's accessible to the user is the same for every query, but the actual query that you're going to generate to Solr is going to depend upon what you got back out from the authority service. If somebody, for example, comes along and flips the switch and says, this user is not allowed to see anything anymore, we just fired him, you don't want it to be cached in Solr for 3 weeks. That would be a bad idea. So it actually does have to be done in real time, and there's a reason that you actually have a separation between what.
The documents have to be marked.
Well, nobody's changing anything in the source system in this scenario. They're simply changing something in, say, Active Directory. They're turning off that user.
Okay.
See what the difference is? Some things you want to take advantage of right away. You want to know if the user's security changes. That you really have to know right away. Manifold isn't going to be able to pick that up until you reindex, but that's not a very typical operation. So, and not only that, but people sort of expect it to take a while before everything catches up. But turning off or disabling a user, they want that to happen immediately. So there's a difference. All right.
Okay, so we've started doing some analytics on the labels and trying to identify, are there any sets of labels that show up somewhat frequently, right? And the idea is we've noticed that the label security adds, it's not as bad as I thought it would be. It adds 20% overhead to how long a query would take, 20 to 30%. And so we've been doing some work around trying to identify which ones show up a whole bunch, and we might pre-warm them. The flip side of that story is we're also trying to figure out which user queries that user's never going to ask again, right? Like it was the last one or the application, and that we're not going to see that user again. And so that would be a case where we would actually use the no filter option to tell Solr, don't bother caching this. It's just going to take up space, and that user, it was a one-time kind of query, and we'll be incurring the cost of that. And we have discovered our cache is not huge, and we're seeing a lot of it being used for the security side, and we really want it to be used for filter queries that are like textual based or other kinds of things. And so that's the other place that no filter might be useful, is to say my security queries, maybe I don't want to cache those, but my facets and other things that might be in an FQ parameter, please do cache them because they're expensive to calculate. So.
Can I just add, I was just going to actually introduce Abe's particular use case, if that was okay. Abe basically works with Ron Hewitt, that's Koji, and I can't pronounce Koji's last name. But his client, a couple of his clients are basically using Manifold to crawl basically shared drives on a pure Windows Active Directory kind of system, and using Solr to index those. This was something that was actually very common also when we were doing this at Metacarta. It was like the most used connector pattern of all of these. Enterprises are particularly fond of this. But that seems to work pretty well at the moment. And so if you have any questions in that particular sphere also, we can bring Abe into the discussion a little bit.
One of the other projects I'm doing with Manifold as well, somewhat similar to his. Everybody familiar with Spotlight on the Mac? I think it's terrible. I mean, I love how easy it is, but I think it's terrible. So I'm trying to do my own version of Spotlight on the Mac and kind of do head-to-head comparison between using Solr for searching on your hard drive versus Spotlight. And again, the sort of Unix file permissions kind of kick in there real nicely with Manifold as well. So, do you want to talk about where Manifold Project's going and the state of it?
I can certainly do that. Somebody's going to have to tell me when to stop because I don't know what time it is.
We have, what, 5 minutes? Okay.
All right. Yeah, Manifold has released a third version from Incubator, and we're working on the fourth version right now. So I guess it's not 4.0, it's 0.4. We're putting in a lot of interesting things. There's a scripting language now that allows you to basically go off and use the REST API directly with, a lot of, it's almost Python-like. It isn't really Python, though, because we didn't want to ship a Python interpreter while we were at it. There's also several new connectors have come on recently. One of them is a CMIS connector, which is a consortium. I don't know what CMIS actually stands for, but it's a consortium. But basically, this is a consortium of content management folks have put this together. The only problem is that they didn't think to give any way of mapping users to ACLs. So anything that's pulled in through this service doesn't actually have the ability to enforce security, which is a little bit of a pain. But the other connector that we recently had contributed to us is Open Search Server, which is an output connector. There's a company, I guess, and I don't know whether they're built on Lucene and Solr or not, but they basically put together a search service that they're using Manifold to populate, and that's pretty much where they get all their documents from. And finally, the Wiki connector, which has just been put together, and we're just kicking it around, is new as well, which allows
specific wiki, or?
It uses the Wiki API.
There's a Wiki API?
There's a Wiki API. So, and you don't like, if anybody's ever tried to crawl wikis with a web crawler, you understand what a pain in the butt this is. So this is a huge advance for those of you who have run your ship against the rocks of wiki crawling again and again. I should have mentioned that Manifold comes with a fairly full-featured web connector as well, which allows you to crawl the web. And that's been, as far as the sort of the theme of Manifold, we spend a lot of time in allowing you to crawl secured sites. So doing session authorization, doing authorization of all kinds, being able to crawl through things that are NTLM protected with the God knows what version of NTLM they finally came up with. We spent a lot of time in making all that work. So a lot of people use this connector, but they couldn't get very far with the wikis because the wikis are just a pain in the butt. So the API allows us to do that. And what else did we do? Do you know?
Well, I was also going to say, can you compare the crawler that's in Manifold versus, say, Nutch as sort of the older one?
Yeah, I can. Since I didn't really go into this in this presentation because it was about security, but overall, the characteristics of Manifold that are important are it's set and forget kind of nature, which basically means you want to set it up and you don't care if that machine gets knocked over, rebooted 18 bazillion times or whatever happens. You want it to pick up where it dropped off and just keep going and keep the content synchronized. That's the goal. Nutch is not built quite the same way. It does have the ability to be restarted, but it's not so easy. There is also the way that Manifold gets this resilience characteristic is by being built on a relational database. So we keep the entire job queue in a relational database, and you can imagine that that puts some performance constraints in the world. So you're not going to go out there and be able to crawl 100 million documents, probably because the underlying SQL store is not going to be that happy with that. It might be if you set the parameters all right and you're, a smart guy as far as database administration, you might be able to get away with that. But most normal mortals aren't going to be able to figure that out so well. On the other hand, Nutch is basically meant to be replicable across many systems now, and it basically has the scalability, but it can't crawl a lot of repositories. It doesn't really have a notion of security. It can't actually, it's not even very good at crawling sites that are secured. So you wind up looking at Nutch more as something for crawling the broad web, and you look at Manifold for something for crawling your intranet and sites that you might have produced locally. I've run it against, I've crawled about 10 million documents in Manifold CF with reasonable success. But I don't think I would want to go beyond that simply because it just gets so heavy to try to move things around and stuff. So, all right. Well, I guess we're done.
Thank you very much.
Good.